This is very important example on the Cauchy's integral formula. If t is a point y's real number and c is a circle mod z equal to 3, then we need to show that this left hand side is equal to this right hand side. Now for this proof, we first need to remember the formulas that cos of theta is equal to e the power iota theta plus e the power negative iota theta divided by 2. And sine of theta is equal to e the power iota theta minus e the power minus iota theta divided by 2 iota, because in the end we need these formulas to get this result. Now the circle given is mod z equal to 3. 3 is the radius of the circle. When taking this denominator equal to 0, we are getting the points z equal to plus minus iota. Are these points lying inside this circle? Yes, both the points lies inside this circle. So we will apply the Cauchy's integral formula for both these points, right? Let's move on to the solution. But before that, we need to make the partial fractions for 1 divided by z square plus 1 whole square. Let's make first the partial fractions of this. And we need to consider our fz to be the numerator, that is e the power tz. This is our fz. This is our fz, right? Okay, now move on to the solution. First, we are going to make the partial fractions for this. How can I write this? It is z plus iota into z minus iota whole square. To make its partial fractions, just write here z minus iota and here z plus iota. You can also write z plus iota over here, it's your choice. When taking this denominator equal to 0, we hide z minus iota from this and we get z equal to iota. Put this value over here. I get 1 divided by 2 iota. So this is 1 divided by 2 iota. When putting this denominator equal to 0, we hide this factor and we get z equal to negative iota. Put this value over here, we get minus 1 divided by 2 iota. Let's take 1 divided by 2 iota outside with the power 2, opening the square of this, and this becomes 1 divided by 4 iota square, that is minus 1 by 4, because iota square is negative 1. So this is minus 1 by 4. Very carefully you have to solve this. Let's take the partial fractions for this. Now our given integral is this one, right? So this given integral now equal to this. After partial fractions, we have separated this integral into these 4 integrals, right? Just multiply both the sides with e the power tz and take the integration, right, over the circle C. We have taken our fz to be the numerator, e the power tz. Because I am having the square in the powers, so if I use the Cauchy's integral formula for the higher powers, for the first derivative, I need the first derivative of fz in the formula, right? So what is the derivative of f with respect to z? It is e the power tz into t. I am writing here t. Very fine. Okay. Now since fz is analytic, fz is e the power tz. It is analytic, which means it is differentiable everywhere inside and on the circle, the given circle, except these points. And these 2 points also lies inside the circle. So now we are going to apply the Cauchy's integral formula for both these points. Let's apply the Cauchy's integral formula first for this integral. Here the point z0 is iota. The format should be z minus z0 in the denominator, right? So what is the formula? The formula is integration fz divided by z minus z0. If I am having the square, dz, then this will be equal to 2 pi iota. If I am having 2 over here, just subtract 1 from this power, we get 1. So take the first derivative of f with respect to z at z0, divided by, if I am having 1 over here, divide by 1 factorial, right? If suppose I have 3 over here, then 3 minus 1 is 2. Take the second derivative and write here 2 factorial. Whatever be the derivative, write the factorial of that number, right? Here power is 2, which is given to us, the power 2. So take the first derivative of f at z0. What is z0? Z0 is iota. So when matching this formula, we get its value is minus 1 divided by 4. Okay, what is the value? Okay, all the numerators are fz. Please write here fz for e the power tz. I have written fz, fz, fz for all these numerators to apply the formula. Okay, now match this formula, we get 2 pi iota, sorry, here it is 1 factorial because I'm having first derivative. 2 pi iota divided by 1 factorial f dash z0, that is f dash z0 is iota. Very fine. Okay, plus for the second integral, what we have? 2 pi iota divided by 1 factorial f dash, what is z0 here? Minus iota, right? Plus iota. Now here there is no power, so a simple Cauchy integral formula without the derivative. Just 2 pi iota into f of z0, right? The simple Cauchy integral formula. So it is iota into 2 pi iota into f of z0 is iota, minus iota into, here z0 is minus iota. So 2 pi iota into f of minus iota. Okay, alright. So this is equal to minus 1 by 4. Let me take 2 pi iota outside of this bracket. We have f dash iota, f dash minus iota, plus iota into f of iota, minus iota into f of minus iota. Cancelling this, we have minus pi iota divided by 2. Okay, what is f dash iota? I'm having f of z to be equal to e the power tz. F dash is t into e the power tz. What is f dash iota then? Just replace z with iota. It is t into e the power iota t. So it is t into e the power iota t plus f dash negative iota. So we have negative sign over here now. So this is t into e the power minus iota t plus iota. What is f of z? It is e the power tz, right? So f at z equal to iota will be e the power iota t. So writing here e the power iota t minus iota f of minus iota. So that will be e the power minus iota t. Right? Okay. Let me take t common from these two terms and iota common from these two terms. And this is equal to minus pi iota divided by 2. Do you remember the formula for cos of t? So instead of this, I am writing twice cos of t. Similarly, for this I am writing twice iota sine of t. And iota square is negative 1, so it is minus 2. Let me take 2 outside from this. So this is minus 2 pi iota divided by 2, and it is t cos of t minus sine of t. So these two cancelled out with this. Let's take minus inside. So we have here negative sign with t cos t and positive sign with sine of t. So this is pi iota into sine of t minus t cos of t. What is on the left hand side? It is this given integral, right? Now because we need 1 divided by 2 pi iota multiplied with this integral, right? So what we are going to do is, let's take this pi iota to the denominator of this left hand side. So this is 1 divided by pi iota and the given integral, and here the right hand side, and let's divide by 2 both the sides. So this is what is required to be proved. Alright, thank you.